Right, Ava, that question that you asked about. Okay, so we've got, what I'm going to do here is divide it into a rectangle and a triangle. So I'll call this rectangle A and the triangle B. Now, remember we're going to use force per unit area. We'll let W equal to the force per unit area. That will allow us to put in some forces. Okay, so A and B. The area of A is 7 by 3, 21 by W. And the area of B, now B is a triangle. So to get the area is half the base by the perpendicular height, which will be half 3. The perpendicular height, that's 7 from there to there, 13 for the whole thing. So this if I said this was the height, then this is half the base by the perp height. That's half of 3 by 6. Half of 3 by 6 is 9. That gives me 9W. Right, centre of gravity of the rectangle is halfway out and halfway up. So that's going to be 3.5 out, 1.5 up. Now, the centre of gravity of the triangle. I need the coordinates of the vertices. So, this vertex here is, if I said this was the y-axis and that's the x-axis, then this point here, of course, is going to be 7W, 7, this point here will be 7, 3. And this one over here is going to be 13, 3. Okay, so they're my 3 vertices. Now remember, the centre of gravity of a triangle is 1/3 the sum of the x's and 1/3 the sum of the y's. Right, so let's have a look. 1/3 the sum of the x's. This one's going to be, I'll do it up here. 1/3 the sum of the x's will be 7 plus 7 plus 13. That's going to give me 27. And the sum of the y's will be 3 plus 3 plus 0. That will give me 6. So 1/3 of 27 is 9. And 1/3 of 6 is 2. Okay, and my centre of gravity is. Okay, now let's find the moments about the x-axis. I'm going to multiply 21W by 1.5. That will give me 31.5W. I'll multiply 9W by 2. That's going to be 18W. This one will be 21W by 3.5. That's going to give me 73.5W. And this one is 9W by 9. That's going to give me 81W. Okay, I'm going to use the law of moments. So I'm going to get the sum of the moments about the x-axis. I'll add them and get 49.5W. I'll add those and I'll get 154.5W. The resultant will be 30W, and I don't know where the centre of gravity is. Right, so let's get the sum of the moments equals the moment of the sum. Let's use the x, see what's happening with the x-axis. The sum of the moments about the x-axis is 49.5 is equal to the moment of the sum is 30W by y. Because there should be a W here. And that gives me y is equal to 49.5 divided by 30, which is 1.65. Then I'll do the moments about the y-axis. So the sum of the moments here is 154.5W is equal to the moments of the sum about the y-axis, which is 30W by x. And 30 will go into 154.5, 5.15 times. So my centre of gravity, 5.15 and 1.65. Second part asks me for the swing. So if this is my point P up here, if it's going to swing around that point, so it'll swing down like that. So remember, my centre of gravity now is 5.15 out and 1.65 up. So it's about here somewhere. So the centre of gravity will have to pass, or the plumb line will have to pass through that centre of gravity. So when it swings around, that's the 13. This will be my 3 bit. That will be the 7. There we go. So my centre of gravity is here somewhere. Okay, so it's going to swing down like that. and this is the angle I'm after, alpha. Okay, so I'm going to get these two values here. So I'll get that value out and that value along here. So that little green triangle then is the one I'm after. Okay, that's my alpha. Okay, so I need these two sides. So that distance out would be the distance along the x-axis, which of course is 5.15 for this bit. Now, the entire length of this is 3. But remember, we moved up. We moved up 1.65. So I'll take 1.65 from 3, and that will give me 1.35 for this bit here. Okay, so I have 1.35 and I have 5.15. So to get alpha, that will be the arctan of 5.15 over 1.35, and that will give me an alpha of 75.3 degrees.